You need to think about security while you're creating software. Very early in our software development education, we learn that programs take some input, do some processing, and produce some output. Very quickly, input and output become incidental, and we focus almost exclusively on processing. Hey, processing is hard. We only study input and output when we take certain specialties like user experience or cybersecurity. But once your code leaves your desk, it's in the real world with real users, humans you know nothing about. They could be a normal user, could be an AI agent, could be a bored teenager running a script they got off the dark web, could be a criminal running 10,000 password guesses per minute. Your code can't expect anything in particular, just a pile of ones and zeros that needs interpretation and processing. It might be 10 megabytes of garbage. It might be a file pretending to be an image. It might be encoded text that hides system commands. To create secure software, you must remember that users cannot be trusted. It doesn't matter how deeply your code is buried in the tech stack from the nearest security boundary or human user interface. It may merely be taking data from one device or framework and handing it to another. But never forget that there's a human at the beginning and the end of that data flow. A human of unknown allegiance, intelligence, motives, capability, and awareness. You should always think to yourself, what if there's a hacker on the other side of the call you're writing? What could they do to your code to break it? What could they do with the data if they get it? There are 3 things you should do to harden your code against a potential attack. First, your code should be sanity checking and sanitizing its input to make sure it's safe, and raising an exception that's properly handled if it isn't. This is called defensive programming, and it's something that every professional developer does. Second, we shouldn't take the user's word for who they say they are, not without evidence. They should present a credential like a key or a certificate that identifies themselves, and we should check it. That's called authentication. Third, we shouldn't let the user do something that they want to without checking if they're allowed to. That's called authorization. Weak or missing input validation, user authentication, and/or authorization are all constantly on the top 10 lists of common weaknesses, leading to a lot of high-impact vulnerabilities. Many operating systems, languages, and frameworks provide facilities and services for you to do all of these things. You should use them. Thanks for watching. In part 2, we'll talk about the output side.